Hi, welcome to Unit 5, Day 10, Types of Chemical Reactions. This is Predicting Precipitates. So this week we've been learning about the 5 different types of chemical reactions. And we have covered all 5 types. And yesterday we started learning about double displacement reactions, and we're going to continue that today. Now remember, the reason why we're learning about these different types of reactions is because by understanding the different types of reactions, we're able to predict products and use certain strategies to balance the chemical equations. Now, yesterday when we started looking at double displacement, we had several success criteria. We defined what a double displacement reaction is. We also learned to predict the products of double displacement reactions, specifically precipitate reactions. And we learned some strategies and employed those strategies to balance precipitate reactions. Today, what we're going to do is we're going to focus on precipitates. So we're going to define what a precipitate is, and we'll use the solubility chart or rules to predict which product is a precipitate, and also if there is no reaction. And then finally, for honors chem, you're required to learn about net ionic equations. So before we dive into what a precipitate is, let's just quickly recap double displacement reactions. So remember, in a double displacement reaction, we start with 2 reactants that are compounds, and we're going to produce 2 new compounds as products. And this happens when the 2 compounds that are the reactants sort of switch ions to form new compounds in the products. Now, there are 2 types of double displacement reactions that we typically learn in general chemistry. Neutralization is the acid-base reaction, but we're not going to focus on that here. We're focusing on precipitate reactions. So let's go over some key points about precipitate reactions. So in a precipitate reaction, the reactants are ionic compounds. So remember, ionic compounds have a metal and nonmetal. And the ionic compounds must be dissolved in water. So because they're dissolved in water, we use the symbol AQ or aqueous in the balanced chemical equation to show that they're dissolved in water. And the phases that things are in for these precipitate reactions are important. So it's important to know what the phases are, if it's aqueous, AQ, if it's solid, S. Now, as we said, the reactants are going to combine to form 2 new ionic compounds. And in this case, the lead nitrate and potassium iodide form 2 new compounds, lead iodide and potassium nitrate. Now, in order for there to be a reaction, at least one of the products must be insoluble, meaning it does not dissolve in water. And this will be indicated by an S symbol for solid. And in this reaction example, lead iodide is insoluble, so it'll be labeled with an S. The other product, potassium nitrate, dissolves in water, so it's labeled with an AQ for aqueous. So remember, if it dissolves in water, it's aqueous. Now that solid product, the lead iodide, that's what's known as our precipitate. So a precipitate is the solid that is formed in a double displacement reaction. Now, in order for there to be a reaction, a precipitate must form. So that means at least one of your products must be a solid. So let's take a look at this reaction in this demo video. So this is the same exact reaction that we saw on the previous slide. Oops, let's go back here. Okay, so in this demo, you have 2 flasks. This flask has lead nitrate in it, and the second flask has potassium iodide. The first thing that this scientist is going to do is he is going to dissolve both of these in water. And he's going to do the same thing with the other one, with the potassium iodide. Just dissolve them in water. Okay, so now that he has them dissolved in water, the next thing that he's going to do is mix them. Now, when he mixes them, I want you to pay careful attention to what happens. What do you notice? What do you see? Wow, let's take a look at that again. All right, so he starts off with two sort of clear, colorless solutions. And when he mixes them together, he forms sort of cloudy yellow solution. That cloudy yellow solution is our precipitate. So what we have in this mixture is we have a ionic compound that's insoluble, and it's also yellow in color. Doesn't have to be, but in this case it is yellow. And that cloudiness is due to the fact that you have some solid that's not dissolved in water. So let's take a look at what's happening here. So we start off with lead nitrate and potassium iodide. They were clear, colorless solutions. If something is dissolved in water, it'll be clear, meaning you can see through it. And then it produced two compounds, potassium nitrate, KNO3, which is aqueous, so that's dissolved in water. It's also colorless, so we don't really see that at all. But it produced that really bright yellow lead iodide, which is our solid precipitate. And we know that we have a precipitate because the solution turned cloudy. Let's take a look at the molecular level, what's actually happening. So how does that precipitate form? Well, when you dissolve an ionic compound in water, the ionic compound breaks apart into its metal cations and non-metal anions. And we can see that here with lead nitrate, it breaks apart into Pb2 plus and NO3 minus. So it's cation and anions. And the same thing for potassium iodide. Now, as soon as he mixes the two together, right before the precipitate forms, you have these ions just sort of floating in solution. So now we have all four ions, the lead ion, the potassium ion, the iodine ion, and the nitrate ion. Now, if one of your products, in this case, it'll be the lead iodide, is insoluble in water, the ions, when they get close together, will clump together to form the solid known as the precipitate. So that's what's happening here. So that yellow cloudy stuff resulted from the fact that the lead iodide, when they got together, they clumped together. They weren't free floating anymore because it formed a solid. So here's some key points about precipitate reactions. First of all, precipitate reactions are an example of double displacement reactions. And the reactants will be two soluble ionic compounds. And they're indicated with aqueous symbol AQ. And we can see that here. The lead iodide and lead nitrate and potassium iodide have the aqueous symbol. The products will be two new ionic compounds, and at least one must be insoluble or a solid. So in our case, the lead iodide was our insoluble solid or our precipitate. So the insoluble product is known as our precipitate, and we know that there's a precipitate because the solution will appear cloudy. Well, the next question you may be asking yourself, well, how do you know if an ionic compound will be a precipitate or not? So let's take a look at how we figure that out. Remember, one of the properties of ionic compounds is that many are soluble in water, but the key word is many. Not all are soluble or will dissolve in water. So to figure out which ones will and will not dissolve in water, there are these things called solubility rules. I'm not going to go through this in detail, but I'll just sort of read through some key points in case you choose to use these. So the first rule states that ionic compounds tells you which ionic compounds are almost always soluble with few or no exceptions. For example, if you have an ionic compound made from a group 1 metal like lithium, sodium, potassium, etc., then that will be soluble. It will dissolve in water. The second rule tells you the type of ionic compounds which are usually soluble with some exceptions, and it'll list the exceptions for you. So for example, halides like chlorides, bromides, and iodides are usually soluble, with the exceptions of those that contain silver, lead, or dimercury. And finally, the last one will tell you which ionic compounds are always insoluble unless they unless they contain group 1 or any noted exceptions. For example, hydroxides are usually insoluble unless they contain group 1 or calcium, strontium, or barium. Now, those are a lot of rules to memorize. So instead of memorizing the rules, what's always a good idea to do is to use what's called the solubility chart. Now, to use the solubility chart, we'll just go through a couple of examples and I'll have you try it on your own. So what the solubility chart shows you is the phase of an ionic compound, if it's going to be solid or aqueous when dissolved in water. To use the chart, you're going to find where the cation and anion intersect. And if it's soluble, dissolves in water, it'll have the AQ symbol. And if it's insoluble, it'll have the solid symbol, S. So let's look for NH4F. Now notice that these are written with the names, so we have to know what the names are. So I'm going to help you out with that. NH4F is known as ammonium fluoride. So the first thing is I have to find the cation, ammonium, and you'll find that on this along this vertical column. So ammonium, I'm going to look for it, and here it goes. So here we are. Now I need to find the anion, the fluoride, and for that you have to look along the top. And there we go. There's fluoride. It's fluoride. So, and it says it's aqueous. So that means that this is soluble in water. Let's do the same thing for our next example. So we'll start with this is silver chloride. We'll start with the cation, and we'll look along the side for silver. Found silver. Now I got to look for the anion, chloride. I look along the top for chloride. Found chloride. And it says it's solid. So if it's solid, that means it's insoluble, does not dissolve. Last example, zinc nitrate. So look for the cation first. Along the side here, we have zinc. That's all the way at the bottom, the last row. And then we'll look at the top for the nitrate. And you got to be careful because there's nitrate and nitrite. So make sure you're looking at nitrate. And there it goes, and it's aqueous. So if it's aqueous, that means it is soluble. All right, now I want you to try it with this CFU. Which of the following will be a precipitate if formed as a product? So remember, precipitates are solids, so you're looking for anything that's going to be a solid. All right, so why don't you go ahead and using the solubility chart, the names are listed there. Pause the video now. When you press play again, the answer will be revealed. All right, the answer to this is C and D. So looking at the first one for silver nitrate, if you find that in the solubility chart, it's aqueous, so that's not going to be a precipitate. The next one is lead acetate. We look for that in the solubility chart, is aqueous, so that won't be a precipitate. The next one is iron hydroxide. If you look at for that in the solubility chart, it's solid, so solid would be a precipitate if it was a product in your reaction. And then the next one, barium sulfate. Again, that's solid, so that will be a precipitate. All right, now what I want you to do is identify the phases of each product and then determine which product is a precipitate. So if none of the products are precipitate, you'll write no reaction. So basically for silver hydroxide and potassium nitrate, you're going to find that in the chart and see if it's aqueous or solid. And then based on that, identify which one's your precipitate. Remember, precipitate will be the solid. Pause the video now. When you press play again, the answer will be revealed. All right, so the answer for that is silver hydroxide is your precipitate, and we know it's a precipitate because if you look in the solubility chart, silver hydroxide is a solid, whereas potassium nitrate is aqueous. All right, try the same thing for the next CFU. Pause the video now. When you press play again, the answer will be revealed. All right, the answer to that is nickel sulfide, okay, because if you find nickel sulfide in the solubility chart, here it is, where the nickel and the sulfide intersect, that's a solid, but sodium chloride, which is table salt, is aqueous. All right, next example. Pause the video now. When you press play again, the answer will be revealed. All right, the answer to that is no reaction. So both calcium chloride and lithium bromide are aqueous. So you have to have a precipitate in order for there to be a reaction. Okay, so let's just end with some key points, some key reminders. So remember that a precipitate reaction, you have to, in order for a precipitate reaction to exist, one of your products must be a solid. That's known as your precipitate, and you can use your solubility chart for that. Next steps, Honors Kim, you do the net ionic play posit, and everyone else take the